All right. Again, I just want to do some quick vibe check before I actually deep dive into my topic. How many of you are familiar or heard about LangChain here? Okay, a few. Okay, no problem. Same with Pydantic. Okay, okay, cool. I think it's okay, no problem. I think people who are not aware of the both technologies or tools, I think they, by the end of this presentation, I think you should get a fair understanding about how these tools will help us in getting the structured data as well, right? Again, some shameless promotion about me. My name is Kalyan Prasad. I was a former data science and analytics manager. I used to lead data science and ML teams. Currently, I'm a freelance data and AI scientist working with some of the Gen AI problems for different sectors, right? Yeah, and also been recognized as top AI and data science voice by LinkedIn. Apart from that, I'm also balancing both academia and industry. During my weekends, I teach for the folks who are interested in the world of data and AI via Great Learning, which is a tech company where I teach there. Other than that, I'm an active contributor to different Python and data science communities. So I also lead a community in Hyderabad as well. Other than this, that's what I do. I always love to share knowledge to people, so that's why I've been there in different conferences and different workshops where I love to give back to the community and all. And rest of the time, that's what I do. I'm like, the fitness freak. I love to travel. I love watching a lot of movies and stuff and all. Yeah, so these are my social handles. Feel free to tag me if you really like my talk, or if you have any feedback for me, please feel free to write a message to me. I'll definitely respond and get back to you for each of your messages as well. Right. So as we all know, right, I'm pretty sure in this room that everybody have used the ChatGPT or Gemini. Yes, right? Great. So when you try to write a message in the GPT, right, you usually get what sort of a response? It's basically a text response, right? You get a text response, you give a prompt, you get a text response, right? But what if they could give you more structured data, which is ready for you doing your data analysis or building your machine learning models and all? So that is something which you directly not get it in your ChatGPT or Gemini, right? So that's where our primary talk focus on today. So now you might be wondering why we actually need the structured data, right? So structured data is really important because it allows us to do more than just reading the information. So that's what, when you try to give a prompt in a ChatGPT or any other large language text model, you usually get the text response, okay, where you read the information. But okay, we know that text is very great at understanding, but structured data is really essential when you want to do any sort of data calculations or data transformations, or even if you want to do any sort of data pre-processing techniques, right? So that's where the structured data plays a very key role. So it's just that, to put it in a very simple way, it's just that instead of getting answers, we are trying to use those answers more efficiently rather than just looking at those responses. That's what we'll be seeing in the rest of my presentation. And typical challenging part is, as I already talked about in the previous point, right? So when a user try to give a request or a prompt in any large language model, right? So you typically get a response, which is like, meaningful text response you'll get, right? If I put it something in GPT, I'll get a meaningful text response, okay, which is very fine, however fine. But this can be very challenging. Text can be a little challenging when you want to use that text to be in your real-time data analysis, or if you want to put that in your machine learning models, right? Right, because you cannot directly utilize that text and feed your model, or directly cannot do the data analysis because text is like, completely unstructured, right? So that's where, so the output that you're seeing on the right side is like, typically you get a response, which is fine. Most of the times it's a text response, okay? That's where challenge. But the very challenging part is if you want to convert that text data into a more meaningful Python object, like, list, dictionary, or even a data frames, right? That's where it makes our job easy. So you cannot directly get that in our LLM model, but how you can do is, eventually we'll understand by leveraging the power of LangChain and Pydantic. So when you combine these tools, right, so you make all this unstructured data into a meaningful Python objects, even like, dictionary or even like a list or even maybe strings as well. So whatever the Python object that you want, you can get it done by leveraging these tools. So that's the beauty about these tools. So on the right side, what you are seeing is the same sort of a LLM response that we are getting from chat, but what we are we are leveraging these two tools and getting the output into a Python usable object so that we can we can use it for our data analysis or even for your ML models and all, right? Right. So again, I think a lot of us are not aware of a LangChain, right? So I thought of again touching upon some foundations here, so that you'll get a clear context about what LangChain is basically and how this LangChain will help us to get into structured data and all. So it's a quite popular orchestration framework for building large language models. There are two familiar orchestration frameworks that are existing in the LLM space. One is LangChain, and another one is like Llama Index, and the beauty about the LangChain is its versatility for developers. So the people who are developing the LangChain applications are like, they are loving it because the versatility is that it's available both in Python as well as in a JavaScript. So people are equally building the applications in both the languages. And another interesting thing is it fairly acts as a generic interface for any LLM, which means that you can easily integrate all your seamless applications with various models. For example, you can get your OpenAI models, you can get your Hugging Face models and integrate, say, easily with LangChain. So that's flexibility that it has basically. And with LangChain, right? So you can not only get the response, you can not only get only the text response from the LLM. So it allows that basically that what kind of a response that you want. For, let's say, if you want a response to be in a list or dictionary or even a data frame, that kind of a flexibility that LangChain basically provides. So basically this ensures that your output is pretty much structured as per your need. So which makes it very much useful when you are building a real world applications. And it also support a lot of advanced workflows beyond simple queries, as I mentioned. So it's not just only work on a simple query. So it can build a lot of advanced workflows that you can build in your data automation and your pipelines while you are building the applications. And another interesting thing about LangChain is it's basically ensured that your application is moving smoothly towards end-to-end phase of from start to end, meaning that so it looks at your LLM model, it looks at your API, it looks at your databases as well. So everything moves very smoothly when you're trying to build applications. So the integration is pretty much smooth when you're trying to build or bring all the external tools at one place, right? So there is no like, tough times or like, there is no possibility of getting stuck in applications when you're trying to bring all this external. So it moves very smoothly and it works very well end to end from start to end. Again, so what is Pydantic? So Pydantic is again the data validation library to check whether if your data is valid or not. Additionally, it also helps in managing and also configuring your Python application. So that's what Pydantic basically is. And another thing about a Pydantic is it basically converts all raw data into well-used Python objects. So as I mentioned, so it converts all the raw. So for example, if we have a value of strings, right? So let's say you have a strings of a number. So Pydantic converts all the strings of numbers into the integers. So it's pretty much do that. And it ensures that data follows strict schema or a template, which means that so that whatever the guidance that you have using, it strictly follows the structure. Let's say if your value is supposed to be an integer, right? So Pydantic will definitely enforce that. So this type of thing will make sure that you're not making any sort of errors, and which will make your application more robust in real time and all. And Pydantic outputs are pretty much validated in a Python objects, like it supports all Python objects like dictionary, list, data frames. So you get all the outputs in any object that you want, which makes it easier for your data analysis, or if you want to build your machine learning models in real time, or even if you have a large data set. Also, this helps pretty much good as well. And yeah, and Pydantic also ensures that your data follows a strict integrity rules, and making sure that whatever the rules or guidance that you have set, it strictly follows the same. In case if there is any sort of thing which is going wrong in your application, Pydantic will definitely catch those things. So those kind of a flexibility and power that Pydantic basically has, so I try to do that so that integrity is very strong when we are trying to do it. And you can also integrate with other Python applications like LangChain to leverage those possibilities. For example, Pydantic ensures that data coming from LLM model and it try to validate that it is rightly formatted or not. So those sort of a cross checks that Pydantic will do when you are trying to integrate the applications with integrate with other Python applications as well. And it automatically checks and validates the data when you are trying to also integrate with external systems like other APIs or other language models, so that everything is smooth. So there is no hurdles in between when you are trying to build this in real time as well. And when you combine the both power of a LangChain and Pydantic, right? So here are some of the things that you should keep in mind when you leverage these both of techniques. And we also parallelly see how this overcome. I mean, like difference between these two comparatively with the plain text processing, right? So firstly is a prompt handling. So Pydantic and LangChain ensure that it handles with the intelligent prompt chaining, meaning that it acts with intelligent chaining of a multiple prompts, and basically it also try to refine and control the output step by step. For example, it means that it checks the data firstly, and based on that, it also, if you want to look at the summary, then it also try to look at the summary as well. Right. When it comes to simple text processing, right, it's just that one-time query where your responses do not have a uncontrolled, where it's not like completely in our control, which means that you ask a question, you get a response in a text, which is fine, but it does not have any sort of a structure or any complex involved queries and all. So this makes the thing that basically when you are trying to work with the plain text processing, it works very well with simple queries or basic queries, but if you want to build, it lacks flexibility if you want to build more complex systems and all, comparatively with LangChain and Pydantic. Okay, and next is data structure. So as I mentioned that outputs are pretty much validated and structured before putting into the model, right? So they are pretty much sorted as a Python objects, so that you can easily play and do whatever the steps that you want to do further as well. When it comes to plain text processing, right, it's completely raw and unstructured. If you want to make it a more structured, right, what you need to do is you need to put a lot of a manual effort here, where let's say you have a list of data. If you want to convert that into a table or data frame, right, you need to put a lot of a manual effort to do things. But with this thing, you can automatically get that when you try to leverage this these two tools, right? And error handling. So Pydantic basically ensures that it strictly validate and type check the data which is coming from the LLM. So it thoroughly check whether the data is completely valid and structured, so that you don't need to worry about the error things and all, because let's say if value is supposed to be an integer, just in case if LLM throws it as a string, right? So Pydantic will try to catch that error. So it makes sure that those are thoroughly tracked, so that so this works very robust on the application side, and which also has a lot of data integrity as well. Right. And when it comes to plain text processing, you need to do a lot of manual validation, which means that this is where your developers need to put a lot of time to write some additional code to do manual validation to check if there are any sort of errors to catch those things and all. Right. Again, integration part is very easy, as I mentioned. So you can easily integrate any Python applications, APIs, and ML models, because our data is completely structured, right? So it's already structured. So you can just straight away take the data and feed your data out to your ML model, because everything is ready. But when it comes to manual processing, right? So you try to require the custom parsing to integrate that with the other systems, because data is completely unstructured. So you need to write some sort of a custom functions here to parse it, so that then only you try to make it as a structured things here. And of course, so the objects are pretty much reusable because all these are Python objects, right? They are pretty much reusable for your further processing and all, which is fine. But in case of a plain text processing, everything is non-reusable because, as I mentioned, so if we have a different sort of object, so if you want to convert one to do, you need to put again a lot of manual efforts here to transform those things from one to other. So that's the little pain comparatively with these two. So I think you have understood now that how by leveraging the power of a LangChain and Pydantic works pretty much efficiency and great in terms over the plain text processing, right? And this is our typical data model that looks in real time. So this is exactly what we try to I also try to showcase you in the demo as well. So this is typical architecture that when we are trying to build the model here. So firstly, we are trying to, so if you look at on the left side, right? So I'm not sure. Okay, let me, just a minute. Okay, so you're seeing my cursor, right? So that is the first step, basically. So what we are trying to do, we are trying to define the different type of output types. So how we define it by defining the OOPS classes. So we are writing through the object-oriented program here. So these classes will use the Pydantic to structure and validate the output data. So this is what the step one is basically. And step two is we are defining a prompt. So what we are defining, we are trying to write a human readable written prompt, okay, which can be easily to understand, and this prompt will be directly used in the chat prompt, so that which will guide the LLMs in generating a response. For example, here is my human prompt, then exent chat prompt. So I'm writing a prompt here. So suggest me some interesting places to explore in Japan. So I thought, okay, this is my first time in Japan, so I thought, let me try to explore some real-time data instead of pulling some data which is already existed. So that's what I do. I also show you practically how this things works as well, right? So I did a prompt now, okay, which is good. Now next what I'm trying to do is I'm trying to create a request, okay? So what I'm trying to craft a request to send it to LLM. So this request is basically will use the parameters that are defined in the Pydant output parser and also in the chat prompt that we have given. And this request will instruct the LLM to act and generate the response to what we ask for. So basically there are three steps that way. First, we have defined the different output data types. Then we are trying to create a prompt and sending that prompt to LLM model. So how we are sending it? By making a request. So when we make a request to our large language model, okay, the large language model will generate a response that, again, it generates a response that what kind of a response that we want to ask for. I mean, what kind of output that we want, it will generate accordingly. So that's what we did so far. Okay, and how we next fourth step is we are trying to configure the LLM model, because three steps are done. What is LLM model? So we need to also configure the model. So the LLM model that we are trying to configure is by leveraging the LangChain. So which our LangChain model will take that request and which will generate the results as well. And finally, the output that we want to get from our results will give you the results. So let's say if you want to get the output to be a list, if you want to get the output to be a dictionary, or even strings, or even a data frame, it will get it, so that you can leverage the data. So that's what this, so basically there are four steps that we use in real time to make the data from unstructured to structured, right? So this is a typical architecture that I built to showcase you on that. So far this is kind of a theoretical part. I also have quite demo to show you how this basically works in a real time as well. So this is the demo that I have built for this presentation. So a couple of installations that you have to do before you have if you want to run this code in real time. So again, you have to install the LangChain library. Then again, you have to install the LangChain community LangCode library as well to support your parser things and all. Then I've also installed OpenAI. I'll tell you why I've installed OpenAI as well. Again, So these are some of the installations that are required. Next is like, I'm installing a couple of suspects. So it's just nothing but some of the libraries that are required to run the show. So that's what I did here. So OS library, where I configure my LLM model, where I keep my API key and all. So that's what I did. And from LangChain LLMs, I imported OpenAI because here I'm taking the OpenAI API key to run my LLM model. So that's the reason why I installed OpenAI here. And chat models I've installed. So both chat prompt template, human prompt template, which are necessary for our model to send a request to our large language model. So that's the reason why I have installed these two libraries as well. Next, I have installed Pydantic output parser. So whatever the parsers that we are providing in our Pydantic, so that will give us the output results. So how we are defining the output parser, based on that we'll get the results as well. That's what it's happening. Again, next I'm importing pandas, JSON, matplotlib. I'll tell you why I have installed all these things in just a few minutes. So these are some of the libraries that are actually required for you to build this thing in real time. Okay, so again, this is what I have done. So what I have done is, so I have my API key. Again, I do not want to show my API key publicly because people might steal and play with it. So there is a cost associated with it. So that's the reason why I just hide my API key. So with this code, right? So it will basically display and ask you for your API key. You just need to put your API key so that your API key is configured in your system as well. Next, what I'm trying to do is I'm trying to initialize the model with the OpenAPI. So just chat OpenAPI is a function model, okay, where I'm passing my API key and also a parameter called temperature. I'm not passing any other parameters as well. So there are a bunch of parameters that you can play with it. So I'm just keeping the model very simple and straightforward here, right? Next, what we have to define is define the output data for model destination. So if you remember when I was talking about architecture of the model, so firstly we have to define the output data types that we want our model to get it. Right? That's what I'm trying to do here. So I've written a quick function here. So where because as I mentioned, my data is basically to explore the destinations and places that are there in Japan. So that's what I'm trying to pull the real-time data and showcase you the things as well. So I've written a quick function here, and I'm giving you two things here. So two conditions. So values is basically a list where you have a field about the list of dictionaries with a destination name, description, category, and average rating. So this is what my list talks about. And next is other one, which is like most popular category, which is in a string format, which basically talks about most popular category of destination across the results. So the three things. So I want to pull all the destination names and category names, average rating names of those destinations and all. And finally, I also want to get the most popular category out of those destinations as well. Okay, yeah. So that's what I've done is, so when I initialize it, then I'm initializing my Pydantic output parser. So I'm passing that output parser. So once I generate the results, right? So this is what you get it in a JSON format. So if you see the results of the output schema, so you have the values description. So these are the things that we are trying to put it in our model. Okay. Next, what I'm trying to is I'm defining the prompt to gather the information and all. So here I'm generating the human prompt and chat prompt. So these are the functions that I can definitely use, and it will pull the values that we have given here. And next is get the results from the model. So whatever the results that we want, our model will help you to get that. Again, so this is like, quick condition. If they're like, kind of a quick data cleaning, if there are any other formatted values which are there in my text data, kindly try to remove it. This is what this piece of code basically talks about. Next, here is the request that I'm passing to my large language model. So give me facts about 100 tourism destinations across Japan, including their name, description, categories, and all. So this is the request I'm putting, and when I get the results, so it will get me the values of a category, average ratings, everything and all. So this is what I did. So, and once I fetch the data and once I result there, so this is what I got the results. So if you see here, I got the most popular places of Japan. Again, I asked for 100, but when I just printed it only with the first 5 values by using the functions here. So because I cannot showcase all the 100 here, so I just thought, let me show the first 5. Okay, so I got all the popular 5 Japanese places, the ratings, as well as the description, everything. So everything I pulled it. Now this is completely unstructured, right? So you see, we got a list of dictionary, under dictionary, we have a list of values here. Okay, this is fine. I got the data output. Now I want to convert this data into a pandas data frame so that I can use it for my data analysis. So that's what I'm doing. I quickly converted that into a data frame. So I converted all these data into a data frame. So you can see we got name, description, category, everything and all, including average rating and all. So out of that, I'm trying to trying the most popular category. So the most popular category across the results is natural. So we have a different category. Natural is one category, landmark, historical. So every place has a different set of categories that we got it. And that's what I got most popular. And even if you try to visualize it, so I also thought of a distribution of tourist destinations by the category of Japan here. And I have try to visualize it. And natural stands out, which means that most of the destinations which Japan has very beautiful nature and all. This is what something I'm also try to explore maybe in next 2-3 days. And rest of them are has other categories as well. So that's what I try to do it in this entire code. It's very simple. So it's just that you are taking the unstructured of a text response and making it to a more structured, and you can do it for your data analysis and machine learning, whatever the stuff that you want to do it, right? So this is what I have done in my talk, and my talk concludes with this. And if I have a time for questions, I'll take it. Otherwise, yeah, so these are some of the references you can explore the LangChain and Pydant documentation, because everything is there in these 2 docs.
Thank you so much. A big round of applause, please.